So we are going to go through this problem just to kind of get that process of completing the square and finding the parts of a parabola, hopefully like solidified a little more. Some of the questions from your homework last night looked like this, where you were completing the square and trying to analyze the parabola. Did anybody find this on Google Classroom? It's there, it's posted. Yes, you know what I'm talking about?
Yeah, it's
Yes. Okay, thanks, Jack. I appreciate it. All right, so we're going to go through this process. On Friday, you have a quiz that is identical to this. The numbers are just changed. So when I say find something similar, similar means it should be pretty much the same type of problem, but the numbers are different. So Friday's quiz is on a problem like the first one with this completing the square, analyzing a parabola. And it should be an easy 15-point quiz because you have one that we're going to complete together that you can then use to study from, but it looks identical to this problem. So let's start off by completing the square. Kaden, what would you do first for number 1 to complete the square?
Subtract -1 to the other side.
Yeah, and I'm gonna change this to be a 0, but I like my 0 to be on the right side. So he said take the -1 to the other side. And then Kaden, in that same step, what else do we need to do?
Take out the -4.
Yeah, take out the -4. Make sure when you take out that -4, you have a +8, you're dividing it by -4, it becomes a -2. Just be really careful with the signs. So completing the square, the first piece here, we have to eliminate C, and then we're factoring out the coefficient in front of the squared term, and just the coefficient. And then, Kaden, what do we do next?
You would take -2 over 2 and square it.
Yeah, you're using that new B value, and when you square that, you get
1.
1. But on the other side, we have
-4.
awesome. Nice job. That's the other part to be really careful with. The -4 must multiply with that 1. And when I was looking at homework, some people are missing that part, and it is going to change your answer. So anytime you factor out a coefficient, that coefficient affects the number that you're placing inside to complete the square to make it a perfect square trinomial. All right, so if we continue this problem, we want to factor it. So the trinomial is a perfect square trinomial, which means it should factor as a quantity now, that same quantity squared. And on the other side, when we combine the two together, -1 and -4 makes -5. So Darby, if I want to have this in standard form, what would my function look like in standard form?
You would have to add the 5 to both sides to make it a function. So it will be f of x is equal to -4 x minus 2 or x minus 1 squared plus 5.
Nice job. So it should be in that form where we have the a, the x minus h quantity squared, and then a plus k. So this is standard form. So we took it from general form when we have ax squared plus bx plus c. We transformed it using completing the square. And now we have standard form. And we can actually do that process with a lot of different functions. And you'll see as we work throughout the year that we will be changing a function from one form to another to make it easier to graph, more graphable. So looking at the questions underneath, Cole, what is the vertex of this parabola?
1 and 5.
Yeah, and then while you're still here, Cole, the axis of symmetry would be?
X equals 1.
Excellent. And don't forget the x equals. He gave it to me. X equals 1. That x equals makes it a line. That's why it says equation, for you to think about that it needs to be in equation form to make it a line. The number 1 is just the number 1. Having x equals makes it the axis of symmetry, which is a line that cuts the parabola in half. Part C and D. So Peter, part C says, what is the y-intercept? What would our y-intercept be, Peter?
It would be 0, 1
And how could you find that?
by going back to the original equation.
Yeah, and if you use the original equation, you don't have to do any work because you're making the x value 0. So it's just that c value. You could also use the standard form, and you could plug a 0 in for x, and then you could simplify it that way as well. Just takes a little work. And then Peter, does this parabola go up or down?
It opens down.
Because?
The a value is negative.
Excellent. So that -4 in front is our a value, and that -4 tells us the graph goes down. It's also a vertical stretch. So that 4 is making it a steeper graph. We talked about that in the last chapter. All right, so the last part here says find the x-intercepts algebraically, keep the answer exact, and simplify if possible. So if we want to find the x-intercepts, Jenny, what would we do to find the x-intercepts?
You have to start from before you put it into standard form. So the -4 x minus 1 quantity squared equals -5.
Excellent. And then what would we do here to find those x-intercepts?
And then you would divide by -4 on both sides. And then you would have to square root both sides.
All right, doing awesome so far.
And then you can square root the bottom of the fraction. So it would be x minus 1 equals the square root of 5 over 2. And then you would add 1. Oh, it would be plus or minus.
Nice job. You
The
got
square
it.
root of 5 over 2.
And
And then you would add 1 to both sides.
Perfect. Nice job. Excellent. So even though we started with a negative number on the right side, when you divide by a -4, it becomes a positive 5/4. We can take the square root of that and we can simplify it. So the denominator does simplify. So just to make this an intercept, so it's an actual intercept or a point on the graph, I'm going to cheat here. Instead of rewriting it, I'm just going to place a comma, a 0 to show that we have a y value of 0 when you're finding an x-intercept, and then parentheses around this problem. Does anybody have questions? You guys did an amazing job. Like, I was just calling on people and everybody was there prepared. So question 35 from the homework was very similar to this question. So kind of look at 35. Did you do the same process? The two problems were very similar. 35 had a coefficient of -2 instead of -4, but the process to work through the problem is very similar. Any questions on this? So we are going to do the other problem on here, which unfortunately, I just didn't have time to squeeze it in yesterday. Sometimes I guess I talk too slow. I don't know. Or half of the people are learning online and it just didn't get to it by unfortunate short periods, I suppose. But this second problem pretty much asks us to do the opposite. So it gives us information about a quadratic function. We have a vertex at 2, 3, and it says this quadratic function, the graph of it passes through a point at 0, 2. It wants us to show the work, and it says you can leave your answer in either form of a quadratic. And when we talk about either form, like we have the standard form, which is what we use to graph a problem, and it has the vertex in it. And then we have that general form. So if you are given the vertex of the graph or of the function and a point that the graph passes through, it makes sense to use standard form because we know the vertex represents h and k in the standard form equation. So I'm going to take this standard form equation And again, I'm using this form because h and k are in this equation. So Jeremy, how do you think you could start finding a quadratic function that has a vertex at 2, 3?
You could plug in the 2 for h and the 3 for k.
Yeah, so plugging in the 2 for h, don't forget it's still squared, and the 3 for k. I don't have an A, B, and C value, so that's why I wouldn't want to use the other form, the general form. The numbers they give me are h and k. It also says that this graph passes through the point 0, 2. Jeremy, how could we use this point 0, 2 to help us in this equation?
And plug in the x to the x value and the y value to the y.
Yeah, so this is really, it's my y-intercept, but the x value of 0, the y value of 2, represent x and y in my equation. So any point that I have that passes through the graph is always an ordered pair of x and y. And again, we can plug those into the equation. So y is 2, x is 0, and then we still have the h value of 2 and the k value of 3. So now this is a little bit of order of operations, and be really careful thinking about order of operations. If I look across my problem, the only thing I have left is A. So that would be what we're trying to solve for. We want to get A by itself. Well, if I want to get A by itself, the first thing that I kind of think about would be, are there like terms that I can combine together? And there's a 3 that's by itself on the right and a 2 that's by itself on the left. And again, our goal is to get A by itself. Well, A right now is connected with those parentheses. So I'm going to move the 3 to the other side because those two are constants and I might as well combine them together. So now I have a -1. The other thing that I'm going to do so that I don't have to write as many steps, with that A value in parentheses, it says 0 minus 2 squared. So Jack, 0 minus 2 squared becomes
4.
4. So that 4 is connected with A. A is in front of the quantity being multiplied. Those values are connected together. And then if you solve for A, Jack, you get
-1/4.
-1/4. So that is now the steepness of our graph. That's that coefficient that represents A. So we got A by itself by taking the 3 to the other side because it was a constant, combining the constants together. Inside the parentheses, 0 minus 2 squared, -2 squared is 4. That's attached to the A value. And then to get A by itself, we divided. So our quadratic function has an A value of -1/4. That's what we had to find. We knew everything else about the graph. We just needed to know the steepness of the graph. And then the H value is 2 and the K value is 3. So now I could look at this and say I have a parabola that goes down. It still has that vertex of 2, 3. Any questions? So just looking at my original information to kind of check your work, just going to make a little sketch here. Just to show you that you can kind of look at your equation and say, yeah, that makes sense. We have a point at 0, 2. And then we have a point at 2, 3. And if my parabola has to connect to that point, the vertex would have to connect with the y-intercept. And the only way they're going to connect is by kind of forming downward. because my vertex, that has to be the highest point of the graph. So I can kind of see that the graph does match with our equation that we found. Does anyone have questions on either of those two problems? Okay, so as I said, I wanted to go over 65 from the book. Number 1 on here would be the process you would want to use for 31, 33, 35. Like it's the same process. So once we're done going through 65, if there are still questions, I can answer any questions that anybody has. But try and like just kind of look at that process and think about that process of completing the square and then answering the parts to the question. It's a pretty big problem. There's a lot involved in finding all of the parts of a parabola. So if you look at your homework, see if you can pull out number 65. The book had a cute little picture, football stadium, couple houses behind the stadium. We will talk about projectile objects in chapter 9 this year. We'll actually be creating our own equations for objects being projected into the air. It's something that's called parametric equations. So we will be able to create this equation using trig. So there's actually trig involved in the equation that is up here. So we will be creating our own equations like this throughout the year, but pretty much closer to like March. But we have the height in feet of a punted football is given by this equation. Y equals -16 over 2025 times x squared plus 9/5 x plus 32. So the values in here are given to you, but we will work through how to find those numbers. And you will be creating equations based off of a projectile object, the velocity, the angle that it's occurring, and all of that is trig and a little bit of physics. So we'll go through that. Part A wants you to graph this in the calculator to see the path of the football. So you were just kind of plugging this in to the calculator. X is the horizontal distance, the Y would be the height. So you can plug that into the calculator, make a little sketch, but like you can see that there is a sketch given, so that your calculator should look similar. If the top of the parabola isn't in your calculator screen, then you would need to change the Y max. So you might need to change the Y max a little bit. You might need to change the X max a little bit to get the whole thing to fit in your calculator. Part B says how high is the football when it is punted? And then in parentheses, it gives us a little hint. Find Y when X is 0. So if we look at our equation, it's telling us to find Y when X is 0. So I'm going to take my original equation and plug in 0. So Peter, what is the height of the football when it is punted?
1.5 feet.
Yeah,
Or
1.5
3 halves.
feet. 3 halves. Because we plug a 0 in for X. So we're really finding that Y-intercept. Where is it starting on the graph, or where is it starting when the football player punts the football? And that's at 1.5 feet. So that's really like the starting position of the graph, the Y-intercept. How high is it when it hits the football player's foot? 1.5 feet above the ground. Part C says, what is the maximum height of the football? Well, if we look at the graph, the maximum height, the highest point, would be somewhere around that value that I put in pink. What part of the graph does that represent? So if I'm
The
finding
maximum.
the maximum, and Peter, what is the other name for the maximum in a parabola?
The vertex.
The vertex. So the maximum height of the football would be the vertex. Now, yes, you can look that up in the calculator. However, this is math class. And unless it specifically says to give the answer using a calculator, we need to have some type of algebraic supporting work. The calculator can be there to help you so you know that you have the correct answer, but we have to have some type of work to support that. So if I look at the original equation, the way you find the vertex could be by completing the square. Completing the square takes an equation and places it in standard form. Well, Peter said find the vertex would be h and k. But if I look at that equation, it has a coefficient of -16 over 2025. It also has a fraction of 9/5 and another fraction of 3/2. Completing the square would probably be extremely difficult. Doable, but definitely messy. So there is another way that we can find the vertex that no, we didn't do yesterday, but I gave you an equation that you could use. So remember, through the vertex is the axis of symmetry, the line that cuts the graph in half. Does anybody remember the equation that I could use to find the line of symmetry if I'm given general form? So we talked about this equation a little bit yesterday. How could we find that line of symmetry where the parabola's vertex is kind of connecting with that line of symmetry? Jenny, do you remember?
You would do -b over 2a.
Excellent. So that's what we're going to do. We're going to try and use -b over 2a, which is still going to be messy because we have fractions, but it might be a little easier than using completing the square. So that's going to get us then the center of the graph so that we can hopefully find the max. So looking, I have -b. My equation is an A, B, C form. So I would use -9/5. And then I'm taking 2 times -16 over 2025. When you place this in your calculator, make sure that you're grouping those two numbers together. And it should work out nicely. So you shouldn't get a crazy answer. It should be pretty nice. So see if you can take -9/5, divide that by -32 over 2025. Or you could say, hey, I'd rather multiply by the reciprocal as well, because that's what dividing is really doing. And you can have a decimal here because, I mean, we are talking about a real life problem. So probably having a decimal makes a little more sense than having an answer as a fraction. Can anybody give me this x value when you take -9/5 and divide it by 32 over 2025?
I got 113.9. Do you want me to say all of the numbers? Like,
Nope, that's fine, Darby. You're good.
Okay.
That's perfect. Yeah. Thank you, Darby. So that 113.9 is my axis of symmetry. So that tells me that I have to go over 113.9 feet. But the question says, what is the maximum height? And this isn't the height, this is how far we're going over. To get the height, we need to know how high we're going up. So what do you think you would do with 113.9 feet to figure out how high the ball would go? So think about, I have X. What do you usually do if you're trying to find the height? If you know the X value?
Plug it into the equation.
Yeah, plug it into the equation because the height is our Y. So how high something goes is always the Y variable. So if I take that 113.9 and plug it into the original equation, we should then have how high the football would go. So we have negative 16, 20, 25 times 113.9. And then 9/5 times 113.9. And then 3/2. Again, plug all that in your calculator. The answer you have after you plug that in should be the maximum height of the football. Don't forget to square 113.9. I forgot my little squared power there. And that number should be approximately 104 feet. Put little squiggles here to represent approximate. So to find a maximum height, you are finding the vertex. To find the vertex, I need to know the horizontal distance the ball would travel. Once I have that horizontal distance, I can plug that into the original equation to find out how high it goes. So it's kind of like a two-part question. They go together. But that would be the algebraic support. So yes, you can look it up in your calculator. If you graph it in the calculator under y equals, you can go to second trace, and there is that max function of your calculator. But this would be the algebra behind what the calculator is telling you. So it's fine to use the calculator as an aid, but we always need supporting algebraic work. The last question here for part D says, how far from the punter does the football strike the ground? I'm going to pull up my little picture again and kind of erase all the scribbles that I put on it. So essentially, we want to know the ball goes up, it comes down, somebody's going to catch it or it's going to hit the ground and somebody's going to run after it. In this case, it says it's hitting the ground. So how far did the punter kick the ball? What would the height of the ball be if it hits the ground? So Jack, how high is the ball when it hits the ground?
0.
0. So if I go to the equation they gave us and it's hitting the ground, that original equation is going to be equal to 0. So 0 is my height when it touches the ground. If somebody caught it, then they would tell me that it's being caught at a certain height. So again, you could look this up in your calculator. You could go to the table of values and find when the y value is 0 in your table of values. So that would be using the calculator as an aid, which is fine. But we also need to have that algebraic support. And if this equation is equal to 0, how would you solve for x? So think about the ways that we know with quadratic functions about solving for x. Option 1 would be to factor.
You would
Doesn't
have to
like,
use the quadratic formula because you can't factor it.
excellent, Darby. So she said you'd have to use that quadratic formula. Darby, do you like the quadratic formula?
I mean, it's not horrible, but not with this problem. It was not done.
I know, right? The other option would be to try completing the square. Again, it wouldn't be horrible, but completing the square would be probably pretty messy too. So you have to use the quadratic formula. I know we haven't talked about the quadratic formula since chapter P, but we did review it in chapter P. So the quadratic formula is that option if you can't factor. If there's no other way to solve, completing the square looks a little messy, then the quadratic formula is probably the only other option. Now, lucky for you, you have a calculator, but it's negative b plus or minus b squared minus 4 times a times c, and then divided by 2 times a. When you're plugging this in your calculator, if you have parentheses exactly like I have it, you should get the correct answer, but I would strongly suggest doing it piece by piece. So I would first just take the numbers underneath the square root and place them in the calculator and get an answer for that. Then take the square root of that number. On the denominator, I would separately take 2 times negative 16/25 and get an answer for that. So I would say, plugging this in your calculator, probably want to do it like in a couple of steps. If you want to plug it all in, make sure you're using parentheses like crazy, but I would just take it piece by piece. You should have about 228.6 feet. That's about how far the punt goes. And if I divide that by 3, then I can get the number of yards. It doesn't ask for yards. But if you're watching a football game, they're going to tell you that the punt was a 50-yard punt or a 60-yard punt. Any questions? So this problem could be really easy if I just said only use the calculator and rely on everything from the calculator. It's a little more interesting when you start having the work and thinking about how to find the numbers the calculator is giving you. So today, there is a review worksheet that is in your packet. And it's also posted to Google Classroom. It doesn't have any word problems on it. So it's just reviewing the quadratic formula, completing the square, and finding information about a parabola. The other problem is a word problem. I think I had it here. Nope, I don't. Here it is. So the other problem for your homework is one word problem similar to that football problem. And this word problem talks about an infant's weight during the first 2 weeks of life. So this is given in decimals, which is, I think, a little better than having those equal fractions. But your goal would be to kind of think about this problem in what it represents. I ask that you graph this function. It does say on graph paper. You can use the graph paper in Notability. It's a perfect tool to use to help graph now that everything is pretty much through that iPad. So if you use the graph paper in Notability, you have a beautiful piece of graph paper. Number 3 says, what was the average birth weight? Number 4 says, when does the minimum occur? So look at the graph after you have it graphed and see if you can think about when that minimum occurs. And number 5 says, what is the minimum weight? You can use a calculator to answer those questions to help you, but you must have work. So the calculator can be there to support your work, but it can't be your actual algebraic work. So the problem that we just went over, those parts of the problems, B, C, and D, that will help you answer 3, 4, and 5. Does anyone have questions? So there is only 3 minutes left. I must have talked too long. I wanted to have a little more time for you. Again, the review worksheet is in the packet. It has a few problems where you're finding the information about the parabola. And then that application problem is similar to the football problem. So you are free to go. If you have any other questions, feel free to stay on and ask. Otherwise, have a fantastic Wednesday.
Thank you.